Hello everyone and welcome to my class. Today we will be learning more about algebra. Okay, I'm going to start sharing my screen. Can you all see my screen? Say yes in the chat if you can. Yes, very good. Okay, so now we will start. So algebra problems 2. This might be a bit hard for you if you haven't went to my last class, but it'll be fine. It won't be that hard. All right, and we're also going to be learning how to complete the square today, because we've already learned what 3 methods we can use. We can factor, we can use the quadratic formula, and if it allows, we can use the square roots. And then there's 4th method, we can use graphing, but we don't use that because that's too slow. And sometimes the numbers aren't whole numbers, so it's not very smart to use graphing to solve a quadratic formula, a quadratic equation. So now we're going to be learning the 5th method, which is completing the square. And then I'm going to be proving the quadratic formula using the general method for completing the square, okay? And then we're also going to be going through some problems. All right, and keep in mind that some of these word problems are pretty hard. They're applying the method, applied problems. And yes, even a plus b squared for completing the square. I'll get to that later. Or it could be a minus b squared. Basically the same thing. You can just switch some signs. So let's begin. Are there any questions on the schedule first though? Any questions on our schedule? Okay, no. Very good. And let's start. So completing the square. How will we do that? Okay. So does anybody know anything about completing the square? Okay, so completing the square. Okay. Where did my PDF go? Of course you mastered it, Stephen. Sorry, I need to hold on. I need to get my PDF up. Accidentally closed it. Okay. What? Okay. Hold on just a second. All right, I got it up again. Okay, I'll share my screen again. All right, so back to the PDF. We are completing the square. So let's start with a very easy one. All right, so how are we going to do this? X squared minus 5 equals 0. So how are we going to do this? This is a pretty easy problem. Please put it in the chat. All right. So, yeah, it is plus minus square root of 5. Great job. And of course, only Steven answers. All right, I need some more participation. Okay, so what you do, there are 2 methods here. Here you can move the 5 to the other side and then square root both sides. X equals plus minus square root of 5. All right, and basically, because square roots, okay, you can have two solutions when you square root. Let's say the square root of 9, that would be 3 or negative 3 because they both work. So basically, x squared equals 5. So then the absolute value of x would be equal to 5. And then get rid of the absolute value, it should be equal to plus minus 5. Square root of 5, actually, square root of 5. Okay, so and then there's another method, but I don't recommend using that right now. That's going to be factoring using our square roots here, basically. Okay, which is just x plus square root of 5 times x minus square root of 5 equals 0, and that's just using difference of squares. And then you assume that a or b equals to 0, so basically x minus square root of 5 equals 0, or x plus square root of 5 equals 0, so you get the answer x equals plus minus square roots of 5. Okay, it's the same answer, but this way is better. Okay, it's faster in this scenario. Well, they're both pretty fast, but okay, so now let's kick it up a notch. Okay, so let's say we have x squared minus 6x plus 4 equals 0. So now I'm going to teach you how to complete the square. All right, so let's solve this. All right, we can solve this by what? We can use the quadratic formula, right? We can use the quadratic formula. So the quadratic formula is x equals negative b plus minus square root of b squared minus 4ac over 2a. All right, and we can just, what are our a, what are our b and c values? Okay, so our a value is just equal to 1. And then our b value is equal to negative 6, c value is equal to 4, and then we can just plug that in to the quadratic formula and get our answer. But we can use another method, which is completing the square. So what you need to do first is you need to move, okay, this negative 4, this 4 to the other side, so you have x squared minus 6x equals negative 4. And then you need, because you basically want this to turn this side into, okay, you want to turn that side into x minus y squared, all right? And then it will be easy because you can just square root both sides, right? And so what you need to do is you need to compare this to this. All right, and let's expand this general formula. It will be x squared minus 2yx or 2xy, but in this case, let's think of it as 2yx, it'll be easier. Plus y squared, all right. And then let's compare that to, okay, let's compare that to x squared minus 6x. All right, so let's first compare negative 2yx to negative 6x. So cancel the x out. Basically, you get negative 2y. No, actually, never mind. It's just 2y equals 6. All right, and then what you get is y equals 3. Okay, so basically you see here, let's just add 3 to both sides because, you know, we just found out y. And then once we add y squared to both sides, then we can just turn this right hand side into this. Okay, so let me give an example of that. So let's do x squared minus 6x plus 3 squared. And since we added 3 squared on this side, okay, to add 3 squared to the other side, 4 plus 9. All right, and then what you get is x minus 3 squared, because this can just be simplified into that, equals to 5. Square root both sides. X minus 3 equals square root of 5 plus minus square root of 5. Don't forget that. And then basically the answer will be x equals 3 plus minus square root of 5, which gives, actually we can't simplify it. All right, so that would be our answer. So does everybody get how we do completing the square? It's all about simplifying the left hand side, or whatever side the x squared is on. Okay, yes, very good. Yes. Okay, good job, Stephen. All right, are there any questions on completing the square? Are there any questions? Okay, no questions? No questions. All right, so I'll take that as a no. And does anybody want to take notes on this? Does anybody want to take notes? Because if you do want to take notes, then I'll leave this slide up for a bit more. Okay, you do not want to take notes. So, actually, let me touch up on some more stuff. All right, so let's say you have this. All right, 4x squared minus 6x minus 3 equals 0. All right, let's say you have that. All right, so what do you need to do first? All right, Stephen, you're familiar with this. How do you do it first? You can't just complete the square with this, right? Let's say you need to solve this by completing the square. Okay, how do you do it? How do you do it with completing the square? Okay, what you need to do, okay, and yes, divide by 4, exactly. So because you must have only x squared when you're completing the square, so you need to divide the whole thing by 4. All right, so divide the whole thing by 4. That's basically just dividing by a. And we're not actually going to solve this. Once you divide by 4, you get a lot of fractions, but it can still be solved. So in general, all right, in general, for completing the square, all right, this is very important, so please take notes on this. Okay, so in general, for ax squared plus bx plus c equals 0, in general for that, when we need to complete the square, basically, what you have ax squared, right? You can't have an a, so you need to divide by that. Let's say it's 1, okay? Nothing changes. Good. Well, let's say it's 4 again, okay? You need to divide the whole thing by 4. So basically, it will be x squared plus b over ax plus c over a equals 0. All right. And then you, because basically, you compare this, right? You compare this. Okay, so you compare this with x minus y squared. All right, let's go back to our old example. X squared minus 6x. Compare that with x squared minus 2xy plus y squared. Okay, so you compare that. And what do you observe about it? Okay, cancel x out. You don't need that. 2y equals 6. Okay? And then y would basically be equal to basically 3. So then you can observe that c here, okay, you need to subtract c from both sides, and then you get plus b over a x equals negative c over a. And then you need to add something. All right, you need to add something. Because what you have right here is negative 2xy. All right, and then you need to have a y squared at the end. So basically, you're just adding b over 2a squared equals negative c over a plus another b over 2a squared. Because that's basically what y squared is going to be. All right. You see here, what is our b in this scenario? B is negative 6. Okay. And then divide that by 2a. Okay, actually, it's going to be 6. 6. Because we can just get rid of the negative sign here. The negative sign is on both sides, so we can just cancel that out. So b here would be turned into 6. And then divide that by 2a, which is just 1. 2 times 1 equals 2. 6 divided by 2 is 3. So that is just y. So that is how we get b over 2a squared. Okay, so now let's move on. Okay, so now what you get is x plus y squared, or x minus y squared. All right, so just simplify this side. Okay, x plus b over 2a squared. All right, so it's already starting to look like our quadratic equation. So in this side, okay, basically will turn into okay, this side will turn into negative 4ac plus b okay, b squared over 4a squared. Okay, so basically you just this multiply by 2, right? Negative what? Okay, 2c over 2a, and then plus that the other side you can do just combine those and then you square, and then okay, you get this. Okay, so after you get this, it's starting to look like the quadratic formula, right? And then you just square both sides. All right, so after you square both sides, x plus what's this, x plus b over 2a equals plus minus p, because basically you need to just square this, because you can combine it, or you can, so it's b squared minus 4ac over, and this can be square rooted actually, so it'll just equal 2a. Okay, and then now it's looking like the quadratic formula. And then you can just combine these two, subtract that from both sides, and you would get the quadratic formula. So basically you derive the quadratic formula from the general way you get you do completing the square. All right, so does everybody get this? Okay, are there any questions on proving the quadratic formula? Okay. So I'm just going to leave this up for some notes if you want to take any. All right. So I hope you have taken your notes. Let's move on. Okay, so now to the actual problems. Okay, so our first problem is an implied problem. Word problems. A 10 millimeter solution is 30% acid. Pure acid can be added to increase the amount of acid to 50%. How much acid should be added? So please put your answer in the chat once you are done. All right. Okay, I'll give you a bit of time to do it. All right. Do you need more time? Okay, I'll give you some more time. I'll give you about 1.5 minutes to do this. And this only needs one variable, okay? All of these only need one variable, okay? Just derive the equation and then solve the problem. Alright. And I accidentally closed my PDF again. Okay. Sorry about that. I need to do this again. Okay, hold on a second. My PDF closed again. So I'm gonna stop my share real quick. This is getting annoying. Alright. Alright, I got it back up. So, besides Steven, who else has an answer? Apparently only Steven has an answer. So sad. Okay, it's quite easy actually. So I am going to show you how to do this. Okay, so basically when you need to add the acid. Alright, so we have a 10 milliliter solution, right? So that's 10. Okay, and the amount of acid is 30%, alright? Multiplied by 30%. And we know that we need to add a bit. Okay, that will be x. Okay, that will be x. Alright, so add x, which is 100% pure acid. Alright, the percentages are representing the amount of acid. Alright, so 10 milliliters, that's 30%. Plus x times 100% equals 10 plus x, and that will be 50%. Alright, so now 50% of 10 plus x. Alright, so now we just turn this into actual numbers. So 0.3, no, actually, that's just 3. 10 times 0.3 is 3 plus x equals 10 plus x times 1/2. All right, so we just need to solve the equation now. It's quite easy. Okay, 3 plus x equals 5 plus 0.5x. All right, and then what you need to do is you need to multiply by 2. All right, because we need to get rid of this decimal or fraction. Okay, 6 plus 2x equals 10 plus x. All right, so now we can just move x to this side, 6 to that side, x equals 4. So what we need to add is 4 milliliters. Okay, that is our answer. Okay, so are there any questions on this? Any questions? No questions. Oh, never mind. I'm not sharing my screen. Okay, sorry. I need to share my screen. Okay, so this is the work here. Okay, so this is the work. So basically, 10 times 30% plus x times 100%. Okay, you should get 10 plus x, so 50% of that. And then you can just solve the equation. And the hardest part about these is just deriving our equations. So it's always good to denote x. What is the unknown? All right. Basically, that is pure acid. How much pure acid should be added to the 10 milliliter solution? All right. Very good, Stephen. Good job. And thank you for reminding me to share my screen. Okay. So, second problem, another word problem. Okay, so car 1 starts driving along a one-way road at 40 miles per hour at 1 p.m. All right, so this is our road. All right, okay. Okay, and car 2 starts driving along the same road at 55 miles per hour at 1:30 p.m. Theoretically, basically assuming that no cars will get in their way, no traffic, no like traffic lights, no, you don't break your tires or something. Okay, theoretically, when will car 2 reach car 1? All right, so you can start working. I'm just going to draw a quick diagram for you. So car 1 starts here at 1 p.m. All right, okay, this looks like Carl. Okay, car 1. Okay, and that's going at 40 miles per hour. Okay. Okay, so, and my pen is acting up again. It's not drawing what I want it to do. All right, okay. And then car 2 starts at 1:30 p.m. and that is driving at 55 miles per hour. Okay, assuming this road goes on forever, when will car 2 reach car 1? All right, so denying, just not paying attention to the length of the road and assuming there are no obstacles. All right, please do this problem and put your answer in the chat. If you don't know how to do it, then wait until I share my answer. And always take notes. All right, always take notes, especially on these problems that you do not understand. Okay, of course, it's Steven. Yeah. Yep, no car crashes or road rage. Nope, just theoretically. Okay, you're just going on forever on a completely straight road. And they have a constant rate. It's quite hard to tell. You have to be specific when you're talking about cars and going somewhere. Make sure you have a constant rate, and you need to be specific. There are no obstacles. The road goes on forever. So car 2 is bound to catch up with car 1. All right. So, are there any answers? No answers? Okay, then I will share my answer. So, basically, you have 2 cars, right? Okay. And then let's have x. Okay. X to be the number of hours for car 1 to reach car 2 to reach car 1. All right, and these number of hours is basically it's going to be after 1:30 p.m. All right, it's going to be after 1:30 p.m. because car 2 drives after 1:30 p.m. So basically, we know that on one end it's going to be 55x because that's basically the number of hours after 1:30 p.m. And that's how far car 2 has drove. Okay. So on the other side, we have 40 times something, right? We have 40 because car 1 is driving 40 miles per hour. And we need to figure out when the distance is equal. But there's a catch. Okay. Car 1 has been driving since 1 p.m. So it already has driven like what 30 minutes before car 2 actually starts driving. So it'll be x plus 1/2. All right. So then we can solve this. All right. So it's very easy. Okay. 40x plus 20. Okay. And then you can easily solve this. Okay. 15x equals what? 20. So x equals 4/3. And 4/3 equals 1 hour and 20 minutes. All right, 1 hour and 20 minutes. So basically the answer here is 1:30 plus 1 hour and 20 minutes. Okay, it will just be 2:50 p.m. All right, so that'll be our answer. You understand? Okay, does everybody understand how we get this? How do we get this? Okay, Steven, do you understand? Okay, this is a um, classic car problem. All right, you're gonna see that in a lot of word problems. Basically, you should, let's say I'm teaching you quadratic equations, all right? You don't need to take notes on every one of them. You just need to take notes on one because you're just gonna solve by using the same way. Not with applied problems. Word problems are much harder. Now you need to devise an equation, and a lot of these I'm teaching are very common word problem types like car problems, and I think the next one is a pump problem. All right, pump A can fill a tank in 3 hours, something like that. And then this is one is an acid problem. Okay, just percentage problem. These are very common types, and you'll find if you take notes on all of them. Okay, one time maybe you'll come across a word problem and then it's gonna fit in one of the categories, okay, with just a bit of modifications. So it's always good to take notes on word problems, and don't waste your time taking notes on every quadratic equation problem. That'd be sad. All right, so now for a pump problem. Okay, pump A can fill a tank in 3 hours. Pump B can fill a tank in 4 hours. If A and B are both used, how long will it take to fill a tank? All right, classic problem. All right, so I don't even need to draw a diagram for this one. So please solve this. And the equation for this is actually pretty simple. Hard to believe. All right. Any answers? Okay, and no answers? All right, so pay attention, kids, since you don't know. So this relates with distance equals rate times time. You've all heard of that physical law, right? Okay, I'm gonna use that a lot. Distance equals rate times time. All right, so A and B are both used. Okay. So X would be the number of hours to fill the tank for A and B. All right, and let me just say the equation is 1 over 3 plus 1 over 4 equals 1 over x. Surprisingly simple, right? So how do we get this equation? How do we get this? Right, so we need to know that speed equals the part of the tank filled over hours. Okay, so that is what we need to understand here. Okay. Okay, so this relates to distance equals rate times time. Basically, speed would be rate. Okay, so distance over time. That's what it would be. All right, and tank part of the tank field would kind of equal distance or amount, and then hours equal to time. So basically the rate. All right, and the amount could be anything. Okay, you can literally this one can be anything. Could be 2, could be 3. As long as it's the same, you'll get the same value. So since it's a fraction, so you can just simplify it later. So what we need to do here is we need to multiply by 12x, right? So whole thing multiply by 12x. Okay, so now we get rid of the fractions. So 4x plus 3x equals 12. 7x equals 12. X equals 12 over 7. And if you want to try it, you can also put 2 in here. You can just put 2 in there and you'll get what, 24 over 14? Okay, it's the same thing. So that is how we derive this equation. Does everybody understand how we do that? Everybody understand? And don't worry if you don't understand the distance equals rate times time part, because we are going to use that in the next problem. Okay. So A bullet is fired horizontally at a target, and the sound of its impact is heard 1.5 seconds later. If the speed of the bullet is 3,300 feet per second, and the speed of the sound is 1,100 feet per second, how far is the target? All right, so how do we do this? Okay, use this. Okay, distance equals rate times time. Use that. All right. Um, actually, we're kind of running out of time. So I'm just gonna solve this for you. All right. So this one is quite similar to the last problem. Okay. We know that one side is going to be 1.5. And what is 1.5? Okay, it's this, what? It's the distance, right? The distance. No, actually. No, right. That's the time. All right, because it's seconds, 1.5 seconds, right? It's the time. And what is time? It is distance over rate, okay? The distance over the rate equals time. So if we have time on this side, then we should have distance over rate on the other side, and then we can just solve for distance, right? It's very easy, okay? But then we have two distances, okay? We have d over, in this case, we can use d or x, but since it's distance, let's use d, okay? So because 1.5 is actually the combined, okay, distance of the combined time, because we need the bullet to hit the target first. Okay, it's hitting the target. Okay, that's a very bad target. This is our target. Okay, we're hitting the target, and the sound is coming back. All right, the sound is coming back. So basically, it's the combined distance. All right. So you also need to add d over 1,100. All right. So now let's multiply by 3,300. Now, these are big numbers, so get out your calculators. All right, so b plus 3d equals 1.5 times 3,300, which equals 4,950. 4d equals 4,950. D equals, that divided by 4 is 1,237.5. All right, so that is how far away is the target. It's 1,237.5 feet. Okay, so we are done here. Are there any questions? Any questions? Do you get it, Stephen? Edward? Anyone? Okay. Derek, do you get it? Yes? Alright. Okay, that's good. That's good. So, now let's solve a couple more problems. Let's not solve that. Let's solve these. Okay? These. Actually, that's pretty easy. Let's solve some more word problems because you guys are having a bit more trouble with these, so I would like to solve them more. Alright, so number 8. A baseball is thrown straight upward with an initial speed of 64 feet per second. Alright. The number of feet s above ground is after t seconds is given by the equation s equals negative 16t squared plus 64t. So when will the baseball be 48 feet above ground? When will it hit the ground? Okay, two questions. Okay, this is A, this is B. So solve both of them. Okay, you can give me A first or B first, doesn't matter. All right, so please do this. Please do this. All right, so I'm going to be expecting answers in a couple minutes. All right, are there any answers yet? All right, no answers. Okay, so this appears to be a bit hard. Okay, so basically, when will the baseball be 48 feet above ground? That's when, okay, number of feet at, okay, basically negative 16 t squared plus 64 equals 48. Okay, that is when it equals 48. Now what do you do? Okay, 48t actually, for 64t. All right, so now what you do is you need to subtract. Okay, negative 16t squared plus 64t minus 48 equals 0. Okay, big numbers, big numbers. What do? Divide everything by negative 16. T squared minus 4t plus 3 equals 0. Alright, so, and to avoid making errors, we're just going to divide it by negative 16 to make it into positive and easy small numbers to work with. Basically, now we need t minus 1, t minus 3 equals 0. Right? Equals 0. Alright. No. Equals 0. Okay. So, basically, t equals 1 or 3. So why do we have two solutions? I mean, there's only one point when it's 48 feet above ground, right? So a baseball, right? It's going straight up, right? Let's say this is 48 feet. It's going straight up. This baseball is going straight up. All right. So when it hits this spot, it's 1 second. Okay, this is 1 second in, but then it's going to fall back down. And when it goes back to 48 feet, it's going to be 3 seconds in. All right, so that's why there's two solutions. And here, the correct answer would be 1 second. Okay, same thing when it will hit the ground. When it hits the ground, it's going to be the number of feet is going to be 0, right? It's going to be 0. So let's do the same thing. Okay. All right. So when that equals 0, t squared plus what? 4t minus 4t. Okay, so after you subtract what? 4t. Okay. Basically, now you just need to factor t minus 4, okay, equals 0. So basically t equals 0 and t equals 4. So 4 is correct here. Okay, gonna go back down, and at that point it's gonna be 4. And 0 is when you haven't even thrown it yet. So that is what that is. All right. Okay, so are there any more questions here? Any more questions? Okay. No questions. Then actually, the next problem is pretty hard and it'll take a bit more time. So we're actually going to end class early today. All right. And we'll do the next problem next time we meet. All right. So thank you for listening, everyone. Okay. Thank you for listening. And okay, you can go now. This is the end of the class. Okay. Thank you for listening.